Hi there. Today, we're diving into the world of heavy-duty vehicle AC systems with MAHLE Service Solutions. We'll be using the ACX 2180 to address cooling issues and perform a basic service common in heavy-duty drivetrains. The ACX product line provides three essential service phases: recovery, vacuum, and charge. Larger systems like this one require more time, especially during the charge phase, but in this video we will provide some tips and tricks to expedite this service. Let's get started. Preliminary checks. Before starting service or diagnosing any AC system, including this heavy-duty one, it's important to follow these preliminary checks. Inspect hoses for damage. Check if the compressor cycle's on and off. Inspect drive belts. Ensure dash vents open and close fully. Make sure condenser cooling fins are not blocked by debris and that the fan operates correctly. Set the heater to off and the system to full cold mode. Performance testing. Now, let's begin servicing the vehicle and initiate performance testing. Step 1. Park the vehicle in a shaded area and note the ambient temperature. Step 2. Connect the high and low pressure service hose couplers to the system's service ports. Step 3. Ensure all dash louvers are open and insert a thermometer probe into the center vent. Step 4. Set controls to fresh air position, maximum cooling, ACE, and highest blower speed. Step 5. Start the engine. Bring engine speed to 1,300 revolutions per minute and allow pressure gauge needles to stabilize. Step 6. Take pressure and temperature readings and compare them to the manufacturer's performance charts that are found in the workshop manuals. Step 7. Once readings are documented, hit the stop button on the interactive screen. Once stopped, remove couplers from the vehicle and wait for hoses to drain. Recovery cycle. Now that testing is complete, let's begin the recovery cycle. Step 1. To expedite recovery time, perform a system recovery on a vehicle that has been static for at least 30 minutes, allowing the refrigerant to enter its liquid phase. During the recovery phase, especially on larger systems, it is common for the procedure to stall as gaseous refrigerant turns into liquid. Heating the system's accumulator with a heat gun before or during recovery will speed up this process. Diagnosing issues. If performance testing shows no component failures, recover the system's refrigerant to compare to the manufacturer's recommended capacity. Often, performance issues are due to a low refrigerant charge. This low pressure could be caused by leaks. Check common leak points like the service port's Schrader valves. Understanding moisture problems. Moisture in a refrigerant system is the underlying cause of most problems. Moisture can be visible, like water, or invisible, like vapor bubbles. No matter what form this liquid is in, it can cause freezing and ice formation at the thermal expansion valve, leading to intermittent cooling. The impact and danger of moisture buildup is corrosion. This poses a threat to the entire system as R134A will hydrolyze with moisture-forming hydrofluoric acid. These acids combined with heat greatly increase the rate of corrosion and attacks all material it contacts. Replacing the AC service port valves after recovery can help prevent leaks. Regular checks and maintenance are key to ensuring the health of the system. Handling PAG oil. Now, let's talk about PAG oil and its interaction with moisture. Unlike most oil-water scenarios, PAG oil used in AC compressors is hygroscopic, meaning it attracts and absorbs moisture quickly. When PAG oil absorbs moisture, it forms a sludge-like texture. This sludge can clog and damage the compressor and other parts of the vehicle cooling system. To remove moisture, use the vacuum pump on the machine. The vacuum turns moisture into vapor, which is then expelled from the system. Remember, a deep vacuum is crucial for a healthy AC system. Regular maintenance and proper vacuuming can prevent moisture-related issues. Now, let's focus on the vacuuming process. Several factors influence the time required to remove all moisture from an AC system. When preparing for the vacuum phase, take the following factors into account: ambient temperature, external restrictions, system capacity, and pump quality. Moisture boils at levels greater than 29.25 inches of mercury. For systems with less than 2 pounds of refrigerant, vacuum for 10 to 15 minutes. For larger systems, vacuum for 20 plus minutes. You can find the refrigerant levels within the vehicle manual, catalogs, etc. Allow the ArcticPRO to perform a vacuum test to ensure the system's integrity and check for vacuum decay. Minimal decay indicates a well-sealed system but doesn't guarantee pressure holding. To guarantee pressure holding, additional pressure testing is required. Keep in mind, the additional pressure testing is beyond the AC machine's capabilities. Replacing components. If issues were discovered with components in the cooling system, follow the manufacturer's recommendations for oil weight and quantity. This can be found in the vehicle's shop manual. If replacing a compressor, drain and measure the oil from the old compressor. Verify the correct amount of oil to be used and fill the new compressor with the manufacturer's recommendation. To ensure pre-oiling has been achieved, turn the compressor hub by hand several times. If large amounts of oil were recovered, it is likely the system contained too much oil and the manufacturer's standards should be used. Charging the system. Finally, let's charge the system. Selecting the appropriate charge method is crucial for larger systems. The charge selection is located at the bottom of the screen and has three options. Option 1, HP high side engine off. Option 2, HP LP charge from both sides engine off. Option 3, LP low side engine running. The best option for large systems is LP low side engine running, and remember the HP hose will not be connected during the charging process. When using LP side charge only, the ACX unit will complete a partial charge amount and start a short hold process before prompting the vehicle to start with the AC low. This allows the vehicle's AC system to pull the remaining charge in and complete the charge. Once the charge phase is complete, it is now time to perform a pressure test. To do so, connect the HS service hose to the port and open the Schrader valve. Monitor pressure readings from both the LP and HP gauges on the ArcticPRO unit. Pressure readings are based on ambient temperature, and if readings don't reflect the chart shown, further analysis will be needed as the system may be defective. High side pressure should be around 175 psi at 77 degrees Fahrenheit ambient temperature. And low side pressure should be close to 32 psi when the compressor is engaged. Another easy trick to remember suction LS pressure. The psi should be close to freezing, or 32 psi, when the compressor is engaged. Once the high side pressure and low side pressure are at the optimal psi, the machine will run one last pressure test. If all checks out, then you will be prompted to detach the machine from the vehicle. And that's it. Thank you for joining us today. Subscribe to our YouTube page for more tech tips from MAHLE Service Solutions.